purpose of this video is to remind you of a few things you may have forgotten about setting up and solving ratios. For the purpose of this example, we're going to look at the ratio 4 to 3 and solve it using cross multiplication. First off, we're going to look at how we can write this as a ratio that we can use to solve problems. So we can say that 4 is to 3 as, say for example, we know that we have 12 of the first thing. How many of the second thing is that going to require? This is one way we could write it. Another way we could write it would be the inverse. 3 is to 4 as x is to 12. Both of these are identical ratios. Additionally, this is an identical ratio. If the 3 is here, 12 is there, 4 is here, and the x is here. This is an identical ratio. We're now looking at how 3 is related to x in relation to how 4 is related to 12, but this is exactly what we're looking at up here. Or we could write the inverse. X is to 3 as 12 is to 4. All four of these will get us to the exact same place and are simply different ways of thinking about the exact same ratio. When we go to actually solve this, we use a method of cross multiplication. We isolate the two numbers which are diagonal from each other and multiply them. 12 times 3 gives us 36. We then divide by the remaining number. 36 divided by 4. Don't have a calculator. Oh, 9. It's good that I can math. X is equal to 9. To show that these are in fact identical ratios, we can come and solve this one. We again isolate the two numbers which are diagonal from each other and multiply them. 3 times 12 gives us 36. We then divide by 4 and once again get 9. That should sound very familiar. Those are the exact same words I just said here. Looking at our remaining two ratios, we can see that these are also identical. 3 times 12 divided by 4. 3 times 12 divided by 4. Taking a moment to look at the explicit algebra that's going on here. Setting up our ratio, 4 is to 3 as 12 is to x. And we'll take this version so that we can talk through the algebra a little bit. The point of this is to show that while cross multiplication is a little bit hand wavy, there's actually explicit algebra going on. So if we were going to solve this equation for x, the first thing we would want to do would be to clear the variable out of our denominator by multiplying it on both sides. This will then cancel, leaving us with our variable in the top. Rewriting this a little more clearly, 4x over 3 is equal to 12. We now proceed with our algebra as normal, multiplying by the denominator. These cancel to 1. And here, once again, we're multiplying 12 by 3, just like in the previous examples. So 4x is equal to 36, which we can then divide by 4 to find that x is equal to 9. So the first step of our cross multiplication had us multiplying 12 times 3 and then dividing by 4. So we see that the explicit algebra comes out identically to the cross multiplication. We use ratios quite a lot in physics and in math, specifically for things like conversions, setting scales, and solving a lot of simple mechanics problems.